Angle properties of circles. Property number 4. Angles in opposite segment. Angle properties of circle. Property number 4. Now, before we begin with property number 4, let's identify this thing called a cyclic-chord. A cyclic-chord is a quadrilateral that lies with 4 of its points on the circumference of the circle. Now, when I have a cyclic-chord, I will have naturally 4 different points. And before we begin to go into this angle property, let us analyze the following. Imagine I were to have a center of circle, and I will draw 2 radius from over here. Now, in my property number 1, we've learned that angle at the center is equals to twice angle at the circumference. So angle at the center is 2 times that of angle at the circumference. If I have a happy face, I must match it with a happy face. Now, if I were to have a sad face, angle at the center, I'll need to match it with the sad face. Now, let's take a look at the angles at the center. What are the sum of angles at the center? Down here. This itself is a point, right? What is the angle at the center if I have both of them added together? This is now 360 degrees. If angle at the center is 2 times angle at the circumference, how am I going to find the sum of these 2 angles? Now, the angle at the center is 360. That means the sum of the angles at the circumference will now be 360 divided by 2. Therefore, the angles here in this quadrilateral, the opposite angles here, they add up to 180 degrees. So this property goes by angles in opposite segment will add up to 180 degrees. Why is it called the angles in opposite segment? Because remember, the Chinese dancer have 2 legs. The anchor point is B and D. If I were to draw a chord, it will cut it into 2 different parts. One is in the major segment over here, and the other one is in the minor segment over here. So these 2 angles are actually in the different segments. So now what do we have for our property name? This is called angles in opposite segment. They add up to 180 degrees. Now, what are the different variations that this can come into? Let's do a few drawings of cyclic chord. First thing, I will need 4 points on the circumference of a circle. Any 4 points. Okay, so if I were to have a cyclic chord, I will naturally have 4 sides. And I'm going to identify where are all these angles in the opposite segment. If, for example, this is my angle A, where will be the angle in the opposite segment? The angle that's directly opposite to it will be this one over here, angle B. So that means A plus B will give you 180 degrees. I can also look for angle C. Maybe this angle C. Then the angles in its opposite segment over here, D. The 2 of them, C plus D, will add up to 180 degrees. Now, can you draw a different type of cyclic chord and try to form this angle property? So it can also probably come in the shape of like that, as long as I have 4 points. Maybe this one over here. As long as I have 4 points all on the circumference of the circle, the property will hold true. So in this case, for example, I will have angle A And the one opposite to it, in the opposite segment, this will be angle B. So angle A plus B will be 180 degrees. And maybe I can have angle C over here. Then the one opposite to it will be D. So C plus D will be 180 degrees. So this is the property for angles in opposite segment. They add up to 180 degrees. Now take out the following worksheet again and let us look at question number 3 on your worksheet. Now this time round we will have more properties to use. The first property will be the Chinese dancer. Angle at center is twice angle at circumference. Property number 2 will be angles in a semicircle. Property number 3, the butterfly. Angles in the same segment are equal. And now we have a new property, property number 4. Angles in the opposite segments add up to 180 degrees. Question number 3. In the diagram, O is the center of the circle. Center of the circle. Which property has center of the circle? Well, the Chinese dancer. Angle at center is twice angle at circumference. Can you see the Chinese dancer? Now I see this. Angle at center, twice angle at the circumference. So if that is 48, immediately I know that this angle over at the center here, happy face with a happy face. So this will be 48 times 2. That gives you 96 degrees. Alright, maybe I should write it neatly. 96 degrees. Okay, next they tell me angle BAD is 48, ODA is 20. Calculate angle OBA. Before we begin, can we look at more properties? Now, let's check. Do I have any angles in semicircle? Don't have any diameter, so no angles in semicircle. Do I have any butterfly angles in the same segment? Not at the moment. Do I have angles in the opposite segment? Let us look for, do you have a cyclic chord? 4 points. I have point 1, 2, 3, 4, all on the circumference. So therefore, I have a cyclic chord. If this is a cyclic chord, what other angles do we have? Oh, angles in opposite segment tells me that this angle over here will be 180 degrees minus 48 degrees. And that gives me 132 degrees. So this is 132. Now, next thing, additional things that we should always take note. Number 1, do you see any radius in this whole diagram? Yes, I have a radius over here. This is the radius, and this is also the radius. If that's the case, I can actually try to form a isosceles triangle over here. Now I can find a couple of different answers. Now let's take a look at question 3, part 1. Find the angle OBA over at this side. What can we use? Okay, not very sure, but I know that this angle at the center here is 96 degrees, right? And then if that's the case, I know that this is an isosceles triangle, right? What other angles can I find? Oh, I can find the base angles of the isosceles triangle over here. And if that's the case, I should be able to identify the triangle ABD so that I can find the angle OBA. So there's a couple steps involved. Let us work them out one by one. The first thing that we know angle BOD is 48 degrees times 2 gives you 96. Why is that so? Because it's angle at the center twice angle at the circumference. Now let us continue to find angle OBD. And OBD is actually equals to angle ODB, which is an isosceles triangle. So 180 degrees minus 96 divided by 2, that gives me 42 degrees. So each of these angles are 42. Now I know that this is 20 and I'm going to find the angle OBA. So angle OBA, using angle sum of triangle in triangle ABD. 180 degrees minus 48 minus 20 minus 42 minus 42 to give me angle BOA, and that will be the answer, 28 degrees. Question number 2. Find angle BCD. Well, I've already found angle BCD when I was doing my question. So part 2, angle BCD means 180 degrees minus 48 degrees and gives you 132 degrees. So this is what we have identified earlier on just now. Angle in opposite segment, they add up to 180 degrees. Have you gotten the answer?